grade 7s, it's time for your natural sciences lesson with me, Helen. What are we going to look at today? Well, remember, we're exploring the periodic table, and what we're going to focus on today is the different regions of the periodic table. So what do we mean by regions of the periodic table? Well, I'm sure that you have been looking at our example of the periodic table that we've been using and asked yourself, why does the periodic table have different colored areas? Well, not all periodic tables are published or printed in beautiful different colors. This is a very pretty periodic table. And you should remember that in our last lesson, we spoke about the alkali metals and we spoke about the halogens. And we can see that the alkaline metals in group 1 and the halogens in group 17, they are all colored in the same. And we can understand that they are colored in the same because they share properties. So the color on our version of the periodic table is to help you remember that different areas or regions in the periodic table have similar properties that they share with each other. So adding color to the periodic table is not essential, but it's wonderful when you are learning about the periodic table. So many periodic tables that you will see in your textbooks or on the internet will be beautifully colored. But as you move towards high school, and if you take science, once you are in grade 10, you're going to see that textbooks have black and white periodic tables, just normally printed periodic tables, because by the time you get to those grades, you should understand the different regions of the periodic table. You no longer need the crutch of color to help you remember the different regions. So we understand it's divided into different regions based on the properties shared by the elements in each region. And we also know that color is not essential. It's there to help us remember and interpret things. Now, can you predict which elements are likely to share properties? Well, we've really discussed this. The elements that are in the same colored blocks are likely to share properties. So our alkali metals are all in those yellow blocks and they share properties, which we discussed in detail in our last lesson. I want you to think of the periodic table like a map, and we're going to come back to this idea in our next few lessons and really see this as a map of all the elements. Now, if I were to show you a map of the world, or even of one continent, say Africa, and I was to ask you, where is it expected, where do you predict the hottest temperatures are going to be? You're going to show me places or regions on the periodic table close to the equator or where there is a desert, because you understand that high temperatures are associated with the equator and with desert areas. So just as we can interpret a map and we can make predictions about what the climate is going to be like in a particular place on the map, so we can make predictions based on the different regions of the periodic table. Because elements that have similar properties, similar reactivity, and remember when we're talking about reactivity, we're talking about the property that elements have to chemically react or combine with each other, not just be mixed physically together. So we know when we look at our periodic table map, we're going to be able to predict reactions, we're going to be able to predict properties. Now in grade 7, you will only look at 3 main regions of the periodic table. So if we go back to our brightly colored periodic table, we'll see that we've got lots of different colors on that periodic table. And when you're in high school, you're going to have to learn about all the different elements and all the different regions. But for grade 7, we're going to simplify it. And we're only going to focus on the 3 main regions of the periodic table. We're going to talk about the metals, and there's an example of one of them. That is an example of nickel. We're going to look at the elements that are called the non-metals. This is an example of chlorine, which is a gas. So already with your understanding of science, you understand that a gas is a non-metal. And when we're making these distinctions about metals and non-metals, at the back of our minds, we must think that we're talking about at room temperature. Of course, we could put this nickel into a furnace and heat it up to a very high temperature, and we could get liquid nickel. But we're talking about at room temperature, or at the natural temperature where this particular element is found. Metals are all solids, whereas non-metals are not going to be solids. And then we've got a very strange group of elements called the semi-metals. Are they metals? Are they non-metals? Well, we're going to look at their properties. The example that I've given you is something that you might be familiar with in terms of silicon. Friendship bracelets, you get lots of these little, they look like they're made out of rubber, but in fact, they're made out of a substance called silicon. If you also look on your bath or in your shower, you'll see that the tile and the bath have been sealed with what also looks like a bit of a rubbery substance, but it's silicon. So that is what we call a semi-metal. We're going to get to semi-metals later. So this is the periodic table that we're going to work with from now on in these lessons on metals, non-metals, and semi-metals. We see that we've divided it, the periodic table, into 3 colors: yellow, red, and blue. So one of these colors indicates the metals to us, one the semi-metals, and one the non-metals. Now we're going to pick a very simple example and a very familiar example of one element of each of these different regions, and you're going to tell me which you think it is. So we're going to start off with the element nickel. We've been speaking about nickel. You've just seen a picture of nickel. And nickel is sitting in the group of other elements that are also colored in yellow. So what do you think all of our yellow group of elements is going to be? Are they the metals? Are they the non-metals? Or are they the semi-metals? Well, having seen that picture of nickel, you should know that what we've given here in yellow is the group known as the metals. Right, so all of our yellow things or elements, symbols on the periodic table show us metals. But let's move to the blue symbols on the periodic table. Let's pick on chlorine. There it is. And you recently saw the picture of chlorine. Chlorine was a yellow gas inside that bottle. So the blue elements, we've already established they're not metals. Are they semi-metals or are they non-metals? Well, the blue elements are the non-metals. We've just seen chlorine is a gas. It's not a metal. And then we come down to our red elements, boron and silicon. There it is. You saw the silicon friendship bracelets. Well, these have to then be the semi-metals. And it basically means they're not metals, but they're also not non-metals. They can't make up their mind. And sometimes people call them, scientists call them the step metals because they make, or the step elements, because they make a staircase dividing the metals from the non-metals. So these are the three groups that we're going to explore over our next few lessons. And we're going to understand what the properties are of metals, what the properties are of non-metals, and finally we will look at the semi-metals. So let's use our current knowledge, what we already know. We haven't looked at the properties of metals, non-metals, and semi-metals in detail yet, but using what you already know, let's make some predictions. So, our question that we're going to answer first is, which group of elements is the most abundant? So when we talk about abundant, we mean the most of, the most commonly found elements on the periodic table. We can choose between metals, semi-metals, and non-metals. So when we look at the periodic table, which group of elements is there the most of? And we see very clearly, I hope you could call it out to me, the yellow group that represents the metals. They are the most abundant. So we think of all of the elements that make up the earth, that make up the universe. In fact, most of them are in fact metallic in nature, or they are metals. Using your current knowledge and using what you understand of the periodic table and its different regions, how many semi-metals are there? Well, that's an easy one. We know that the semi-metals are those indicated in red on our periodic table. So let's count them. 1, 2, 3, 4, 5, 6, 7. We know that there are 7 semi-metals. The semi-metals are the rarest group of elements on the periodic table. We can see that metals dominate, and the semi-metals, we would say, are the least abundant elements on that periodic table. If you were given a sample of xenon, and that's the chemical symbol for xenon, would it be shiny and hard? Well, let's look for xenon on the periodic table. So we can go up and down, we can go along the different periods, we can go down the different rows, and there we have it, xenon. Would it be shiny and hard? Well, remember that shiny and hard are properties of metals. No, this is a non-metal, so no, it would not be shiny and hard because it is in fact a gas. All right, and our last question, which element appears out of place in the periodic table? Which element looks like it's wandered away to somewhere else? And we see that it's good old hydrogen. Hydrogen is put over here on the periodic table. We know that it's a gas, so it's a non-metal, but it's placed in terms of its reactivity over the group of alkaline metals, even though it isn't a metal. So we've got one element that seems to be put out of place. Don't forget that one of our non-metals is placed above the group of metals. So we're slowly starting to understand more and more about the periodic table. And when we talk again next time, we're going to continue our exploration. But for today, goodbye.